For this problem, we want to evaluate the integral by interpreting it in terms of areas. The integral of the absolute value of x minus 3 from 0 to 6. Here, I just want to make a quick note that whenever we talk about these topics, be it derivative or integral, we can always look at it in terms of a graph. For example, the derivative is the slope of the tangent line. So when we look at a graph of a function, we can draw the tangent line at any point and then we can just calculate the slope from there. The same is going to go for the integral. As stated before, from 5.1 and now 5.2, the integral is the area underneath a curve. Right now, we don't know how to evaluate this integral as is, but we do know how to draw the function, and we do know how to find the area. So let's draw the function. This is an absolute value function that has been shifted 3 spaces to the right, meaning if you put in 3, you should get 0. If you put in 4, you should get 1. And if you put in 2, you should get 1 as well. Connect the dots. Now, we want to find the area underneath this curve from 0 to 6. So 4, 5, 6. Here we note that the picture to the left is a rectangle. Here we note that our 2 figures form a triangle. So the integral from 0 to 6 of the absolute value of x minus 3 dx is going to be equal to the area of the first triangle plus the area of the second triangle. What is the area of the first triangle? It's going to be 1/2. The base in this case is from 0 to 3. So the length of the base is 3. And where is this location? What y value is that? That is precisely when you put in 0 into the absolute value function, meaning it's just 3 itself. Then the area of the second triangle, 1/2. 6 minus 3, the base has length 3 still. And the height, well, if you put in 6, you will still get 3. And then we just add them up. 9/2 plus 9/2, meaning just 9. Any problem that you encounter of this kind asking you to evaluate the integral, you can do it by first drawing the graph, and then just look at what area do you have to add up. Next, let's try this problem. Exact same idea. We are going to follow the exact same steps. First thing we want to do is to find the graph. This is a graph of a linear function that has been shifted to the right by 1. Meaning if you put in 1, you should get 0. If you put in 2, you should get 1. And if you put in 0, you should get -1. Connect the dots. So this is the function f of x equal to x minus 1. Now, they are asking us for the area from 0 to 3. So we have a1 and a2 just as before. The integral from x minus 1 dx is equal to, well, in this case, we want to note that a1 is underneath the curve. And whenever you see an area underneath the curve, you are actually subtracting the area. So to find the total sum, we actually have negative a1 plus a2. Keep that in mind. Area under the x-axis have to be subtracted. And then we calculate. Again, these are just two triangles. So 1/2. A1 have a base of 1. It have a height of 1. And there's a negative in front. A2 is above the x-axis, so we add, so it's still positive. It have a base of 2, and if we put 3 into the function, we have the height is also 2. So this is -1/2 plus the 2 cancel out.